Yes, welcome to the night class. We're doing the rational root theorem today. That sounds all mathematical and stuff. It's not too bad. Rational, what does rational mean? What's it the fancy word for? Fraction. If it is a rational number, you can write it as a fraction. Okay? So the root, that's the fancy word for the solutions. When you say solve, you're finding the roots, okay? Remember the roots. What else do we call them? Zeros, x-intercepts. Those only work if they're real, right? Okay? Solutions, all of these things mean the same thing, okay? So if it's a rational root, these are all the solutions that are rational numbers, okay? So what does that mean? That means it can't be irrational. So we're not talking about the square root of 2 answers. We're talking about an answer that you can write as a fraction. Everybody got it? All right? So,
when do you make that test
we can do it today if you're ready. Whenever you're ready. Whenever you're ready.
It don't matter.
Doesn't matter to me. All right. Example 1 says list the possible rational roots of 6x to the third plus 11x squared minus 3x minus 2 equals 0. Then determine the rational roots. So we are basically doing the same thing we did yesterday, okay, with a little bit more to it. So first, we have to list the possible rational roots, okay? So the possible rational roots, we talked about this yesterday. What number did we look at to get the possible rational roots yesterday? The last one. Now, yesterday, what was the first number every time? 1. So today it's a little different, okay? So I don't know why they call this, but this is your P, and that is your Q, okay? And basically, the last number is your P, the first number is your Q. You have to find, to get all the possible rational roots, you have to find all the factors of P. So what are the factors of negative 2?
2 and 1.
Plus or minus 1, plus and minus 2. Okay, don't forget the plus or minus, because it could be positive 1 or negative 1, could be positive 2 or negative 2. Okay? What are the possible factors of Q? Q is 6. So 1, 2, 3, and 6. Everybody with me so far? To get the possible answers, the possible rational roots, you divide your P by your Q's. Okay? So P divided by Q, 1 divided by 1 is 1. So plus or minus 1. 1 divided by 2 is 1/2. 1 divided by 3 is 1/3. 1 divided by 6 is 1/6. And again, it's plus or minus all of these. All right? Then you do the next one. 2 divided by 1 is 2. 2 divided by 2 is, we already wrote it. You don't have to write it twice. 2 divided by 3 is 2/3. And 2 divided by 6 is 1/3, which we've already written. So these are all the possible rational roots. Yes, but in a smaller scale. Okay, like I said, yes, we did this yesterday. But yesterday, my Q was always 1. You may have done an algebra 2. I'm not sure. I can't remember. Okay? So, just like yesterday, it says, then determine the rational roots. So, I have to figure out which, there's 1, 2, 3, 4, 5, 6. 6 times 2 is 12. So there's 12 possible answers. And normally you would have to take each answer and do what with it? Plug it in. But remember, I told you I'm going to let you do what? Graph it. So graph this and tell me just one answer where it's crossing the x-axis. Will it give you all 3? Yes. But I just want 1. Okay? Just give me 1.
-2.
-2. So I'm going to come over here. Let's see where I got room right here. -2. And I plug in. I lost my problem. Let's see here.
It looks like you're not going to have, well, since you have fractions.
6 11, negative 3, negative 2. And we do our synthetic division just like we did yesterday. So bring down my 6. That will be negative 12, negative 1, 2, negative 1, 2. I get 0 like I am supposed to. Okay? So I'm left with what? 6x squared minus x minus 1. I don't know why I put 6. All right? And we factor that if we can. Okay? If we can't, we know x plus 2 is our only factor. But what do we have to do to factor this? Multiply the 6. So we're going to borrow. Okay? So this is going to, I'll move this over here. X squared minus x minus 6. That will be x minus 3 and x plus 2. Everybody see where I'm getting those numbers? Negative 3 times 2 is negative 6. Negative 3 plus 2 is negative 1. We borrowed the what, though? The 6, so we have to divide by 6 to put it back. So our final answer, we got, let's see here, x minus 1/3, x minus
Plus 1/2.
or plus 1/2. Oh, I'm sorry. I got my numbers mixed up. It's x minus 1/2 and x plus 1/3. Okay? And then what's my other factor? X plus 2. So I'll just put it right here. Now, since they asked for the factors, we talked about this yesterday. They didn't ask for the solutions, they asked for what? The factors. So I don't need to leave these as fractions. What do I do with the bottom numbers? Where do I move them? You just put them in front of the x. So my final answer is x plus 2 times 2x minus 1 times 3x plus 1.
Coach Knight, I have a question.
Yes.
What you did right there, that thing right there, the x squared minus x minus 6.
Right.
What is that called?
That's called borrowing. Okay, so I borrowed the 6 by multiplying it by that last number. That gives me this. Okay?
Yes, sir.
And then you factor this.
So, for some reason in my head, I thought that was completely square.
That is not completing the square.
And so, the complete square is where you divide by 2
And square it, correct. Yes, ma'am.
Okay, I understand that, but like at the beginning, your Q and P. Go
Yes.
back over that again.
Okay. P is simply the last number, and Q is the first. And your P's are all the factors of P, and your Q's are all the factors of Q. All right? And then to get all the possible answers, you just divide all the P's by all the Q's. Okay? So like I said, without your cool little graphing calculator, you would simply be taking these numbers, plugging them in, and seeing which one gives you 0. Is that making sense? So you had 12 possible, but how many we only had how many that were actually work? 3. So 9 of them aren't going to work. So again, I'm just trying to save you time so you don't try, no, and especially this one, because to be honest, if I'm trying them, I'm going to try all the whole numbers first. I'm not going to do the fractions, and there's quite a few fractions. So I would have tried 1 and -1 and 2 and -2 first. And the only one that would have worked out of those 4 would have been the -2. You follow me? And I would have had to figure out, all right, so you don't have to do that. You can graph it and get 1, okay? And I noticed y'all graphed it and you picked the integer. That was smart, okay? Because if you can't tell where it's crossing the x-axis, don't pick that one. Okay? You couldn't tell because one of them was negative 1/3 and one of them was positive 1/2. So I understand why you couldn't tell. All right? Any questions on that? Everybody good? So again, you're doing the same exact thing you did yesterday, only you have to list the possible answers and then tell what are the factors. Okay? All right? Yes, sir. The P, again, is the last number. The Q is the first number. The P's are the factors of the first number, or the last number, excuse me, and the Q's are the factors of the first number. That's where I got it. Okay? All right. Example 2. It simply says find the roots. So we don't actually have to define the P's and Q's here, okay, because it didn't tell me to find the possible rational roots. So we're just kind of skipping that step and going straight to answering it, okay, solving it. So, graph x to the third plus 8x squared plus 16x plus 5, and figure out where does it cross the x-axis. And I just need 1, okay?
So it doesn't matter which one you use when you do it?
It does not matter which one you use, because whichever one you use, it's going to give you the other 2. So if you use a different one, you'll get the one, like, say I'm speculating. You use 1 and I use 2.
Exactly.
Well, if you use 1, one of the answers you get is going to be 2. But if I use 2, one of the answers I get is going to be 1. It doesn't matter which one works. It's what? -5 works? All right. So we got 1.
I'm 3 for 3.
-5. -5 times 3 is 15. -15, excuse me. That's 1. -5 times 1 is -5. We get 0. Again, if you don't get 0, something is wrong. We're left with x squared minus or plus 3x plus 1. Now, again, the difference here is we're not finding the factors, we're finding the what? The roots, okay? You know what? I messed up on this last problem, didn't I? Because the last problem, we were supposed to be finding the roots as well, and what did I find? The factors. I was doing it like we did yesterday, but I should have left it alone. What were my roots? -2, 1/2, and -1/3. Sorry about that. Again, they didn't ask for the factors, they asked for the roots. Okay? So, won't make that mistake again. So, here, can we factor that? I know one answer right now is x equals -5. We used it, okay? We used it to find this. Can we factor this? You can't, because what are the factors of 1? Is there 2 numbers that multiply to be 1 that add up to 3? No. So how do we solve that? Quadratic equation, or I'm double checking my question. Had it said find the rational roots, would I be finished? Yes, because if you have more rational roots, I should be able to factor this. Okay? So if you can't factor it, that just means you don't have any more rational roots. Is everybody with me? But it doesn't say rational roots, it just says what? Roots. So you're just finding the roots no matter what. So x equals -5 is 1, and then you can do one of 2 things. Complete the square or quadratic formula. I agree. Let's do quadratic formula.
I wanted to see you complete the square because I kind of.
We'll do another complete the square later. What is B? 3. What is A? 1. And C is also 1. So we're going to get, let's see here, -3 plus or minus the square root of something all over 2. And what is the something? 9 minus, what, 4? 5. If it says to round your answers, you would need to put those in your calculator, but it doesn't say that, therefore you can just leave it like that. Okay? But understand, in your calculator, you would put -3 plus square root of 5, enter, divide by 2, get that decimal, and then you do -3 minus square root of 5, hit enter, divide by 2, and get that answer. Okay? But since it didn't say round, you can leave it like that. But understand, there's one real answer. These are not imaginary, they're still real, they're just what kind? They're not right, they're irrational. Okay, and remember, I told you, imaginary answers and irrational answers always come in pairs. Okay? Everybody good? All right. I believe this is the last one. See this guy? This guy's named Descartes. I don't know. Like I said, I took French, but I don't speak it. So he was a French mathematician. he came up with this little rule of sines. And to be honest with you, it's just kind of neat to know, but you don't have to know it, okay? It's a shortcut, but it's not a big deal, all right? So it says find the number of possible positive real zeros and the number of possible negative real zeros. So to begin with, we're not even finding the zeros. We're just figuring out how many there are of each, okay? So here's what his rule of sines says. To get the positive real zeros, you count how many sign changes there are. Okay? So 2x to the fifth. 2x to the fifth is a positive, right? Plus 3x to the fourth. Is that positive? Minus 6x to the third. Did the sign change? So there's 1. Okay? Plus, did the sign change again? There's 2. Minus, sign change again. 3 plus. So how many sign changes were there? 4. That means there are 4 positive real solutions, or zeros. Okay? That's the tops. It could be less than that. Okay? Here's where you have to remember, okay, what's true about this. They go down in pairs, always. Okay? They always go down in pairs. So if there could be 4 positive reals, there could also be what?
4 negative.
Nope. 2. Or there could be what? None. Okay? So when you write your answer, you have to include that with it. Just remember, you always go down by 2. So there, oh shoot. All right, how did I do this yesterday? I went to home and backed up. Oh, huh. I didn't mean to do that. There it is. Okay. So there could be 4 or 2 or 0 positive real zeros. Okay. To do the negative real zeros, you do the same thing, but you plug in negative x first.
Wait, I'm confused. How do you have... Oh, wait, never mind.
Okay, sure.
Yeah.
Okay. F of negative x, so I'm just going to plug in negative x everywhere. I see an x. And again, you have to do this when you're finding how many negative zeros there are. That's long, huh?
That's a little bit long.
Very long. So this is going to stay negative. This will become positive, or stay positive, I guess I should say. That will become positive. Negative to the third power is negative. Times a negative is positive, right?
Oh, okay.
Negative squared is positive. Negative times a negative is positive. And positive 3. Okay?
So, the first
So
one,
Uh,
how many times does it change sign?
Once.
Once. So there is 1 negative real 0.
So we have to do the 4, 2, 0 thing every time on the positive? Which it won't
You have
work.
to do this. You have to do this every time you have more than 1. So had there been 6, your answers would have been 6, 4, 2, and 0. Had it been 5, your answers would be 5, 3, and 1. Okay? Every time it's more than 1, it goes down by 2s.
Why do you have to write that?
Because there's these other answers, okay? Just to show you. We had 4 positive real. How many negatives did we have? 1. That adds up to what? 5. Okay, so our choices, we could have 4 positives, 1 negative, that's 5. If we had 2 positives and 1
Oh,
negative,
it's for the
what are the other
imaginary.
2? Imaginary. Okay?
Oh, doesn't that go back to the thing that we had to do, the lesson that we learned?
Yeah, the
about it?
complex, yes. So if we had 0 positive, 1 negative, that means the other 4 have to be what? Imaginary. So they go down by 2 to accommodate for the imaginary answers, which always have to come in pairs. Okay, does that make sense?
Yes, sir.
Okay, so technically, you didn't have to do all this because you know, hey, if I got 4 positive and I can only have a total of 5, that only leaves me how many negatives? 1, okay? But they may not ask you to do both. You understand? They may just say, hey, how many negatives do you got? Okay? Now, to check our answers, it says then determine the rational zeros. All right? So to do that, we would have to do our dividing, okay, 3 times because it's to the 5th power. We got to get it down to be a quadratic, okay? So I'm just going to let you use your calculator on that one to figure it out, okay? But just to show you, well, all right, read it to me because it was long. It was 2x to the 5th,
Yeah,
or,
it's 2x
right?
to the 5th plus 3x to the 4th minus 6x cubed plus 6x squared minus 8x plus 3.
Gracious. All right. So notice we have 1 negative 0, 2 positive. So that means the other 2 must be what? Imaginary. Okay? So our total, we could have had at most 4 positive, but we didn't. We had actually just 2. Okay? But understand, they're wanting to know what are the actual answers. So that answer is what? Negative 3. This one is 1/2, probably. And that one's 1. Okay? Do you know how to get them if you're not sure? You do. You can hit second and trace, and you're looking for the what? The zeros. All right? So I would go to number 2. I'm not going to do this one because it's pretty clear it's going through negative 3. That one's very clear it's going through 1. I'm only going to find this one. So same thing. You have to do the left bound and the right bound. Okay? So I need to be to the left of it. I hit enter. I scroll over to the right, but I don't go so far. You can't go past. See, that would be too far because I passed the other 0. Okay? You don't want to pass the other 0. So there you go. Enter, enter, and it is 1/2 like we thought. Okay? All right? Any questions? All right. That's it for the day. Hope everybody has a great day. If you can't get out of it, get into it. And as always, stay above the line.